Oil tankers Part 5. Tank cleaning. Tanks must be cleaned from time to time for various reasons. One reason is to change the type of product carried inside a tank. Also, when tanks are to be inspected or maintenance must be performed within a tank, it must be not only cleaned, but made gas-free. On most crude oil tankers, a special crude oil washing (COW) system is part of the cleaning process. The COW system circulates part of the cargo through the fixed tank cleaning system to remove wax and asphaltic deposits. Tanks that carry less viscous cargoes are washed with water. Fixed and portable automated tank cleaning machines, which clean tanks with high-pressure water jets, are widely used. Some systems use rotating high-pressure water jets to spray hot water on all the internal surfaces of the tank. As the spraying takes place, the liquid is pumped out of the tank. After a tank is cleaned, provided that it is going to be prepared for entry, it will be purged. Purging is accomplished by pumping inert gas into the tank until hydrocarbons have been sufficiently expelled. Next, the tank is gas-freed, which is usually accomplished by blowing fresh air into the space with portable air-powered or water-powered air blowers. Gas-freeing brings the oxygen content of the tank up to 20.8% O2. The inert gas buffer between fuel and oxygen atmospheres ensures they are never capable of ignition. Specially trained personnel monitor the tank's atmosphere, often using handheld gas indicators which measure the percentage of hydrocarbons present. After a tank is gas-free, it may be further hand-cleaned in a manual process known as mucking. Mucking requires protocols for entry into confined spaces, protective clothing, designated safety observers, and possibly the use of airline respirators. Special-use oil tankers. Some subtypes of oil tankers have evolved to meet specific military and economic needs. These subtypes include naval replenishment ships, oil bulk or combination carriers, floating storage and floating units, FSOS, and floating production storage and floating units, FPSOS. Replenishment ships, known as oilers in the United States and fleet tankers in Commonwealth countries, are ships that can provide oil products to naval vessels while on the move. This process, called underway replenishment, extends the length of time a naval vessel can stay at sea, as well as their effective range. Prior to underway replenishment, naval vessels had to enter port or anchor to take on fuel. In addition to fuel, replenishment ships may also deliver water, ammunition, rations, stores and personnel. Ore bulk oil carriers. An ore bulk oil carrier, also known as combination carrier or OBO, is a ship designed to be capable of carrying wet or dry bulk cargoes. This design was intended to provide flexibility in two ways. Firstly, an OBO would be able to switch between the dry and wet bulk trades based on market conditions. Secondly, an OBO could carry oil on one leg of a voyage and return carrying dry bulk, reducing the number of unprofitable ballast voyages it would have to make. In practice, the flexibility which the OBO design allows has gone largely unused, as these ships tend to specialize in either the liquid or dry bulk trade. Also, these ships have endemic maintenance problems. On one hand, due to a less specialized design, an OBO suffers more from wear and tear during dry cargo onload than a bulker. On the other hand, components of the liquid cargo system, from pumps to valves to piping, tend to develop problems when subjected to periods of disuse. These factors have contributed to a steady reduction in the number of OBO ships worldwide since the 1970s. One of the more famous EPOs was MV Derbyshire 180,000 DWT, which in September 1980 became the largest British ship ever lost at sea. It sank in a Pacific typhoon while carrying a cargo of iron ore from Canada to Japan. Floating storage units, floating storage and floating units, FSO, are used worldwide by the offshore oil industry to receive oil from nearby platforms and store it until it can be offloaded onto oil tankers. A similar system, the floating production storage in a floating unit, FPSO, has the ability to process the product while it is on board. These floating units reduce oil production costs and offer mobility, large storage capacity, and production versatility. FPSO and FSOS are often created out of old, stripped-down oil tankers, but can be made from new-built hull. Shell Espana first used the tanker as an FPSO in August 1977. An example of a FSO that used to be an oil tanker is the Knock Nevis. These units are usually moored to the seabed through a Sprague mooring system. A turret-style mooring system can be used in areas prone to severe weather. This turret system lets the unit rotate to minimize the effects of sea swell and wind. Pollution and oil spills have devastating effects on the environment. Crude oil contains polycyclic aromatic hydrocarbons, PAHs, which are very difficult to clean up and last for years in the sediment and marine environment. Marine species constantly exposed to pests can exhibit developmental problems, susceptibility to disease, and abnormal reproductive cycles. By the sheer amount of oil carried, modern oil tankers can be a threat to the environment. As discussed above, a VLCC tanker can carry 2 million barrels, 320,000 meters squared, of crude oil. This is about 8 times the amount spilled in the widely known Exxon Valdez incident. In this spill, the ship ran aground and dumped 10,800,000 US gallons, 41,000 meters squared, of oil into the ocean in March 1989. Despite efforts of scientists, managers, and volunteers, over 400,000 seabirds, about 1,000 sea otters, and immense numbers of fish were killed. Considering the volume of oil carried by sea, however, tanker owners' organizations often argue that the industry's safety record is excellent, with only a tiny fraction of a percentage of oil cargoes carried ever being spilled. The International Association of Independent Tanker Owners has observed that accidental oil spills this decade have been at record low levels, 1/3 of the previous decade and 1/10 of the 1970s, at a time when oil transported has more than doubled since the mid-1980s. Oil tankers are only one source of oil spills. According to the United States Coast Guard, 35.7% of the volume of oil spilled in the United States from 1991 to 2004 came from tanked vessels, ships/barges, 27.6% from facilities and other non-vessels, 19.9% from non-tanked vessels, and 9.3% from pipelines, 7.4% from mystery spills. Only 5% of the actual spills came from oil tankers, while 51.8% came from other kinds of vessels. The detailed statistics for 2004 show tanked vessels responsible for somewhat less than 5% of the number of total spills, but more than 60% of the volume. Tanker spills are much more rare and much more serious than spills from non-tanked vessels. The International Tanker Owners Pollution Federation has tracked 9,351 accidental spills that have occurred since 1974. According to this study, most spills result from routine operations such as loading cargo, discharging cargo, and taking on fuel oil. 91% of the operational oil spills are small, resulting in less than 7 metric tons per spill. On the other hand, spills resulting from accidents like collisions, groundings, hull failures, and explosions are much larger, with 84% of these involving losses of over 700 metric tons. Following the Exxon Valdez spill, the United States passed the Oil Pollution Act of 1990, OPA-90, which excluded single-hull tanked vessels of 5,000 gross tons or more from U.S. waters from 2010 onward, apart from those with a double bottom or double sides, which may be permitted to trade to the United States through 2015, depending on their age. Following the sinkings of Erika, 1999, and Prestige, 2002, the European Union passed its own stringent anti-pollution packages, known as Erika I, II, and III, which also require all tankers entering its waters to be double-hulled by 2010. The Erika packages are controversial because they introduce the new legal concept of serious negligence. Air pollution from engine operation and from cargo fires is another serious concern. Large ships are often run on low-quality fuel oils, such as bunker oil, which is highly polluting and has been shown to be a health risk. Ship fires may result in the loss of the ship due to lack of specialized firefighting gear and techniques, and fires can burn for days.